Okay, so today we are going to be changing fractions into decimals. Now this is really easy to do. We're just going to do the operation that we see. So this actually means something. 3 over 4 represents an operation, and the operation is division. So what this actually says is 3 divided by 4. Let me zoom out for you. 3 divided by 4. So if I tried that in my calculator, 3 divided by 4, it's going to give me the answer. It's 0.75. And we should know 3/4 is 0.75. Okay? But today we're going to practice it without a calculator, but you can always use one to check your answer. So how do we divide without a calculator? We're going to use long division. Long division. Now that sounds scary. It sounds like something we didn't like to do in elementary school, but it's actually pretty easy on these. Okay, so we're going to do 4 divided by 5. Let's write it out so we know what it says. 4 divided by 5. And we don't have to write it out every time. What does that look like? 4 divided by 5 looks like this. Okay, so I'm going to ask myself, how many times does 5 fit into 4? If you said 1, you're not thinking. How many times does 5 fit into 4? It doesn't fit into 4. It's too big. So the answer is actually 0. 5 does not fit into 4. And so what we need to do is we need to make 4 big enough that 5 can go into it so we can get an answer. Now we can't change this number into anything we want because then we've changed the problem and therefore the answer is going to be different. But what we can do is we can add a decimal and a 0 because 4.0 is the same as 4. 4 equals 4.0. It's the same thing. Okay? So what I can say is now how many times does 5 go into 40? So it's 4.0, but I can ask myself how many times does 5 go into 40? And that's 8. I'm going to put that up here. And it goes exactly in. So I'm done. I don't need to do anything else. There's no remainder. The one thing I haven't done yet is put the decimal in my answer, and that decimal always goes straight up. So my answer here is just 0.8. And if I wanted to double check myself, I'd grab my calculator and I would just do 4 divided by 5. And there you have it, 0.8. There's my answer. So if I slide over to 3/4, I know that this one is 0.75, but how do I get that answer using long division? So 3 divided by 4. 4 doesn't go into 3, so I'm going to put a 0. And instead of 3, I'm going to make it 3.0. And now 4 can go into it. Now before I move forward from there, I automatically want to bring this decimal up. I suggest you do it right away. That way you don't forget later or put it in the wrong spot. So now I can ask myself, how many times does 4 go into 30? The answer is 7, but it doesn't go in perfectly 7 times, so I'm not done. So just a reminder how you do long division, you're going to find out what's 7 times 4, and you're going to subtract it from the original number. Find the remainder. So 7 times 4 is 28. Subtract. That's 2. And now, if you remember, I got to bring down the next number. So what is the next number? Well, the next number is actually a 0. I can add as many zeros as I want here, and I'm not changing the number. 3.0 is the same as 3.00000, as many as you want. So I'm bringing down the 0. 4 goes into 20 exactly 5 times. So since it goes in exactly 5 times, I am done. And then we get the answer that we knew it was, 0.75. Nice. So let's see what happens when we have some bigger numbers. Maybe we got to use some different strategies. So I'm going to take 19 and divide by 20. Well, 20 doesn't go into 19, so I'm going to say it goes in 0 times. I'm going to add the decimal and add a 0. So now this number is 190. Even though it's 19.0 technically, I'm going to think of it as 190. And now 20 can go into that. Before I do anything, let's bring up that decimal to our answer. And now we got to figure out how many times does 20 go into 190. Well, I know 20 times 10, right? That's 200. So if 20 times 10 is 200 and puts me just over 190, that means instead of times 10, I'm just going to do one less. So it's going to be 9. It goes in 9 times. Think about what 9 times 2 is. 9 times 2 is 18. So instead of 2, it's 20. I just add a 0. So if 9 times 2 is 18, 9 times 20 is 180. Now, if I subtract here, I get 10, and I need to bring down another 0. 20 goes into 100 5 times exactly. Since it's exact, I'm done. My final answer here is 0.95. And again, if I wanted to check it on my answer, on my calculator, it's 19 divided by 20.95. All right, next one. Something goofy happens here. So if we do 1 divided by 25, well, 25 doesn't go into 1. So nothing goofy yet, kind of the same. Add a 0, bring up my decimal. Here's the problem. I've made this number bigger, but it's still not big enough for 25. 25 does not go into 10. Now, I need to represent that. So I need to put a 0 up here. And now I need to make this 10 even bigger so 25 can fit. So I'm going to add another 0. 25 goes into 100 4 times. Exactly 4 times. So my answer is 0.04. Where students will make a mistake, though, is they'll keep adding the zeros and they'll get to 100, but they won't fill in these spots up here. And so what they'll do is they'll say 1 divided by 25. They put the 0. They add it, and they say 25 doesn't go into 10. So they add another 0. Okay, it goes into 100 4 times. And they say the answer is 0.4, but that's incorrect. Okay? Since it doesn't go into 10, I need to represent that calculation with a 0 and fill in that spot. 0.04 is different than 0.4. This is the correct answer. Notice, too, that I haven't just been circling the answer on top of my division. Okay, I want you to write it separately, especially when we get to these last two. It's even more important. So if I come down to number 5 and 6, these are kind of the 7th grade material. These are not going to be regular decimals. They're going to be decimals that go on forever, and in this case, repeat. So let's see what happens. If I divided 1 by 3 in my calculator, and I'm going to skip to this one first because it's easier. If I go to 1 divided by 3, you'll notice it's 0.3333. You just see a bunch of 3s, and they would actually continue on forever. So the answer is 0.3 repeated. And we'll talk about how we write that in a second. But what does it look like when we're trying to divide and we get a repeated decimal? So 3 does not go into 1. I put a 0, put my decimal, add a 0, bring it up. And 3 does go into 10. How many times? 3 times. But not exactly 3 times. So 3 times 3 is 9. And I'm going to subtract. That's 1. Bring down the 0. I've got 10. How many times does 3 go into 10? Well, 3 times. 3 times 3 is 9. 10 minus 9 is 1. Bring down the 0. And I got 10 again. And if I keep doing this, I'm going to keep getting a 3 up here. I'm going to keep getting a 9. And I'm going to keep bringing down a 0. And I'm going to keep getting a 10. And I'm going to keep asking myself, how many times does 3 go into 10? And I go over and over and over. And I can literally do this all day, and it's not going to change. So I need to recognize that I'm asking myself the same question. Notice the pattern. All right, and recognize the answer is a repeated decimal. So how do I represent this? It's going to be a bunch of 3's repeated. So I'm going to write 0.3. And since that number is being repeated over and over and over, I have to put a bar on top of it. And that tells me that it's going to go 3, 3, 3, 3, 3, 3, 3, 3. So that is my final answer. Now, technically, you could write 0.33 like this. Because even if I go 3, 3, 3, 3, 3, 3, 3, 3, it's going to say the same thing as 3, 3, 3, 3, 3. So technically, you could even do this. And it says the same thing. And technically, you could even put a 3, a 3, a 3, and just over here, because it's going to go 3, 3, 3, 3, 3, 3, 3. They all actually say the same thing. But this is the simplest form. This is what we're looking for. We always want the simplest answer. This is the simplest form. So this is the one I'm looking for. When you give me an answer, just 0.3, repeat it. So let's try number 5. 5 divided by 99. So 99 definitely does not go into 5. So 0. Bring my decimal up. Now this is going to be similar to number 4 because 99 doesn't go into 50. I added a 0, I made this bigger, and it still doesn't fit. So I must fill in this blank up here with a 0 to show that it didn't go into 50. Now I can make this 500, and 99 does go into 500. Now if you can't do that off the top of your head, round this up for a second. Pretend 99 is 100, and how many times would 100 go into 500? Well, 5 times. And since this is less than 100, it's going to be just less than 500. So 5 is going to be my answer. Now, how do I do 5 times 99? A couple different ways. So I could just write it out and do it the old-fashioned way. 99 times 5 is 45. 9 times 5 is 45. Add the 4 to the 45 and you get 495. The answer is 495. What's another strategy for that? So you could split the 99 into 2 pieces. You could say 90 times 5, and that's 450. And then you could do just the 9 times 5, and that's 45. And if you add those together, you're also going to get 495. So 2 different strategies for getting that. Some people also say, well, I know that 100 times 5 is 500. So I took 1 less every single time, all 5 times that I multiplied it, it's going to be just 5 less than 500. So it's 495. So whichever way works for you. But 5 times 99 is 495, which when I subtract leaves me a remainder of 5. Okay? Put a 0, bring it down, and I get 50. 99 doesn't go into 50, so I must put the 0. That's huge. A lot of mistakes are made right there. So since it doesn't fit into 50, I have to put the 0 in there, and then I have to bring down another 0 to make it 500. And at this point, you should realize, man, I already did this. So this is probably a repetition. So 99 goes into 500 5 times. And if I multiply, I'm going to get 495 again. I'm going to subtract. I'm going to get 5. Bring down. I'm going to get 50. And I'm back in my same old here. So if you notice the pattern, it's going to go 0, 5, and 0, 5. And it's going to keep going 0, 5. So my final answer, I need to write it as 0, 5 repeated. Now you need to be really careful with this line, because if you just put the line over the 5, that's a different answer. You're saying it's 0.0555555. Only the 5 would be repeating if you put it just over the 5. So since it's 0, 5, 0, 5, that's the pattern, then both digits need to have this line over it. Okay, it shows that it repeats. And just like I said before, you could technically put 0, 5, 0, 5 with a line over all of it, because if that keeps repeating, it's going to be the same as this. But this is your simplest form. Okay, so make sure the line also doesn't go over this 0, because that 0 is not repeating. Only this one and this one. Now, if you saw this on a calculator, you might get confused. So 5 divided by 99. We see the 0, 5 pattern. 0, 5, 0, 5, 0, 5, 0, 5. And then all of a sudden there's a 1 here, and that confuses students. They say, well, the pattern doesn't continue. There's a 1. The problem is your calculator only has so much space here. And so the last number that they put, they're going to round it. And you've done a lot of rounding in your life. So since this went 0, 5, 0, 5, this is supposed to be a 0. But the next number they left off was a 5. And the 5 bumps that 0 up to a 1 when they round. So this is rounded. So if you ever check your answer on a calculator, you need to kind of ignore that last spot, okay, because it could throw you off. It's not really a 1 there. It's a 0. They just rounded it. So it is 0, 5, 0, 5, 0, 5, 0, 5. Okay. So what I want you to do is I want you to copy down these 3 problems, 3/5, 4/9, and 6/11, and I want you to try those on your own. When you think you've got these right, and I need to see all of your work, long division, use your calculator to check your answers. Okay, so do 3 divided by 5, 4 divided by 9, 6 divided by 11. You could even do it before you do it so you know what you're working towards. That's not a bad strategy. And then when you think all your work matches the correct answer, raise your hand. I'll come over, I'll check it, and I'll get you your homework, and you can start practicing this stuff.